This video is on the topic of gravitational potential energy. An object has energy in its gravitational potential store if it is raised through a gravitational field. For example, this skier has energy in their gravitational store at the top of the hill, and that energy is transferred away from the gravitational store and into the kinetic store as they ski down the slope. It's important to understand that there are many examples of energy transfers to and away from gravitational potential stores. Common ones are lifting objects up and then dropping them, and bouncing balls or people on trampolines. Less obvious examples that can crop up in exam questions are objects in orbit and objects below ground. For example, if you visit a tube station or underground car park and take the stairs to the ground level, you would be transferring energy into your gravitational potential store. That's why it's important to define the gravitational potential energy store as an object being raised through a gravitational field rather than being raised above ground level. So what is gravitational potential energy? It's the amount of energy in the gravitational potential store of an object. The amount of energy an object has in its gravitational potential store is dependent on three things: the object's mass, the gravitational field strength in that location. Remember that the value of G varies depending on where you are in the universe. For example, it's 9.8 newtons per kilogram on Earth, but only 1.6 newtons per kilogram on the Moon. And the change in height as the object moves through that gravitational field. Although we talk about gravitational potential energy when we're using the equation, always remember to use the energy store terminology when answering worded exam questions. Let's take a look at an example exam question. A rifle fires a bullet of mass 0.015 kilograms vertically upwards through the air. As it leaves the rifle, the speed of the bullet is 330 meters per second. Calculate, firstly, the energy in the kinetic store of the bullet as it leaves the rifle for 3 marks, and then the maximum possible height that the bullet can reach, also for 3 marks. Notice here that the question is asking about both the kinetic energy and the gravitational potential energy of the bullet. This is very common. Most exam questions will link these two topics in this way. So for part 1, to calculate the kinetic energy, we need to recall the kinetic energy equation, and that's the first mark. Then we substitute the known values into the equation. We have 1/2 times a mass of 0.015 kilograms times a speed of 330 meters per second, remembering to square the speed. The second mark is for the correct substitution. And when you plug those numbers into your calculator, you should get 816.75 joules. However, the mark is given for the correctly rounded answer. Here we're working with two significant figures, so we round to that, giving a kinetic energy equal to 820 joules, and that's the third mark. For part 2, calculate the maximum possible height that the bullet can reach. We know we're dealing with gravitational potential energy, so we write out the equation. There's no mark for that this time, but often there will be, so never skip that step. The key here is to recognize that for a small object like a bullet, air resistance would be negligible, and therefore the energy transfer between the kinetic and gravitational potential stores can be assumed to be 100% efficient. That means that all the energy from the kinetic store of the bullet will be transferred to the gravitational potential store as the bullet travels vertically upwards. Recognizing this is important because it gives us the missing variable needed to solve the equation. If gravitational potential energy is equal to kinetic energy, then we can say that kinetic energy is equal to mg delta h. So we know the kinetic energy, we know the mass, and remember that we also know the gravitational field strength on Earth is 9.8 newtons per kilogram, and you are expected to know that. So rearranging the equation to solve for h gives delta h is equal to kinetic energy divided by m times g. The correct rearrangement will earn you 1 mark. Next, we substitute in the known values. We've got kinetic energy, Notice how we use the unrounded value here to avoid compound rounding errors. That's divided by mass at 0.015 kilograms times gravitational field strength at 9.8 newtons per kilogram. The correct substitution will earn you that second mark. Plugging that into your calculator will give you delta H is equal to 5,556 meters, which again we want to round to two significant figures, leaving us with 5,600 meters as our final answer for the last mark. In summary, gravitational potential energy is the amount of energy in an object's gravitational potential energy store. The amount of energy in an object's gravitational store is determined by three things: the object's mass, the gravitational field strength of the location, and the change in height of the object. Exam questions will often be multi-step calculations, so you may need multiple equations, such as the kinetic energy equation, or you may have scenarios that involve two different heights. Don't forget to check out all our other fantastic revision resources here at Save My Exams.